Hello, fellow ex-citizens. In today's episode, it's going to be one of those topics that is important. It has a lot of safety implications, and it is going to be about electricity, about electrifying your homes and your businesses in Liberia. So, this discussion is focused on Liberia, and it is all about electrification of your homes and your businesses. So, why are we talking about this today? The reason is simply because uh, I have seen a lot of people make poor choices when it comes to what type of wires they use to electrify their homes or to connect their homes to the grid electricity in Liberia. Sometimes these can have severe ramifications, and we all know that there has been a couple of incidences in the past couple of years that many people even prominent Liberian citizens have had a bad situation where their house catches on fire. Now, I don't have the data, right, to support any hypothesis that, what percentage of these fires, these terrible incidences are caused by poor electrification, right, or poor wiring. I don't know. I don't have the data for it. But I think it is a reasonable hypothesis to say that a significant portion of house fires that are caused in Liberia, specifically in Monrovia, is due to poor electrification. So, in today's episode, and this problem doesn't affect only the poor people in Liberia, it affects people from uh, all band of the economic ladder or the economic spectrum, right? So we have very powerful Liberian with a lot of money, but yet some of their properties will catch fire. And not all of it, again, but potentially some of these are caused by bad electrification. So today we are going to talk a little bit about that. So before we begin, first, let's talk about how your entire home or your business is electrified and what are the pieces, right, that goes into electrification. So at a high level, these are the following components. If you say your home is powered, right, it has electricity, these are the components that comes with that. One, how that power is generated. So that's the generation of your power. So for example, if you have electricity from the grid, right, that is supplied by the Liberia Electricity Corporation or LEC, that power is most likely generated by the hydropower plant at Mount Coffee or is generated by some heavy diesel generators, right? If you are getting power from your solar, your own portable solar systems that you've built, that power is generated, of course, by the solar panels converting sunlight into electricity. So that's the first thing. So the generation aspect, and you will see exactly how we get to the wiring part, right? So these are the components. We have to understand these components because these things will affect your choices down the line. So bear with me. Hang on for a second. So this is the generation part, right? The next thing, when you generate power, you have to transmit that power, right? And transmitting that power means you are taking that power from the site where it is generated to where it is going to be utilized. So another word for it is either transmission or distribution, right? So sometimes they can be used interchangeably or sometimes they can be used at once. But at the home level, right? Let's take the case where you generate your power from your solar systems. The transmission of that power just means how that power gets from your solar panels to most likely an inverter box in your building. Or for the case of the grid electricity, LEC handles the transportation or the transmission of your power from the generation site all the way to your community and also to your generator house or to your building's transformer box, right? So that constitutes the transmission and the distribution part, right? At a large scale, the distribution, basically LEC handles that again, how they take power from Mount Coffee, for example, and distribute that power in different communities, right? And then transmit that power down to your building. But at the level of a single building independent power generation unit, the transmission just talks about like, how do we take that power and bring it down to your inverter box? And then how do you run that wire from your inverter box to the various appliances and the loads that are going to consume that power. So that part is very important, and that is the part we'll be dwelling on because that particular component deals with uh, a lot of critical systems that you have to put in place. And the number one critical thing is the choice of wire that you choose. So we'll talk about that. The other component of your entire power system is going to be the storage. How do you store energy? And this particularly concerns people, for example, who use a battery backup system. And this is mostly closely associated with people who use solar power panels, right? So the solar panels will generate power for you in the daytime, but the sun is not shining at night, so the panels do not generate power at night. So you need to store that power somewhere. So again, you basically transmit that power from the solar panel in the form of DC electricity, and that DC power goes into your inverter box. Your inverter box uses that power to charge your batteries, which is the storage of your power. So what battery choices you make if you are using solar panels is also another thing to consider if you are going the solar panel route, right? So that is the storage part, right? So I think those are the major components that we want to look at today. And of course, the other part now is the load part, right? What choices of load you use, because that is also critical, like what appliances, especially in Liberia. Actually, we shouldn't downplay this part. And we can discuss these components in details later. As I said, we are going to be talking about the power transmission and distribution part today. But the load part, for example, the Liberia electricity system is based upon the 220 voltage system, 220 to 40 voltage system. So if you are going to use appliances that you are taking from the US, most of those appliances are compatible with the 110, 120 volt system, right? So if you are taking appliances, you probably, if you are going to use it with the grid electricity in Liberia, you probably need these transformers. And most often you want to buy the two-way transformers, i.e. those transformers that can both convert from your 110 to 220 and vice versa, right? So they will take your grid electricity in Liberia at 240 voltage and break it down to the 120 voltage so that you can plug your appliances from the US. And I just want to make that clear, the 110 volt and 220 voltage are the two different voltages, the wide range, and then you have the 120 volt, but most appliances that use 110 volt will also use 120 volt. So those are the same. So all your US appliances are 110/120, and then the appliances you will buy in the local market in Liberia, because the voltage there is 220, will be the 220 or 240 volt system, right? So if you're taking appliances from here and are going to use them on the Liberian grid, you want to make sure that you have a couple of transformers. And the best types that you want is the ones that go both ways, because you never know, one day you may have the need of taking 110 to 220, right? 110 power to 220 power. For instance, if you use the grid electricity, you will always use the 220 broken down to 110 for your US appliances. But should you think of adding solar installation to your home in the future, then you may also find yourself in a situation where you bought some appliances in Liberia and those appliances are 220. So the day you don't have grid electricity and you turn on your solar power system to supply your building with power, those 220 systems will need transformers for you to step up the power from the 110/120 to 210 to 220/240. So that's why it's good to get the two-way transformers, or sometimes they are called step up, step down. But let's pack all of that discussion. So let's come to the transmission and the distribution part. This is the main topic of our discussion today. So the transmission and distribution of electricity. And we are not going to talk about what the grid the providers are doing from the source of their generation all the way to your house. We are only talking about if, for example, you have your power line, when they drop your LEC line to the transformer in your community, the wire you are going to run from that point to your home, right? Those are the choices we are going to be talking about. How do you make those choices? And then when that line comes into your home, normally it comes into a panel box into your home. How do you take the wire from that panel box now and start connecting your lights, your stove, your oven, your water heaters, etc., right? So that is where you are distributing the power in your building. What choices do you make there? And specifically, we are going to be talking about the choices of wires you are going to be using. And this discussion is also going to, I think, be biased slightly towards people who are running wire for their homes and for maybe small businesses. And I'll mention the small business in particular for small commercial buildings because I am actually in the process of building a small commercial building, which is the XHQ building, right? So, and one of the reasons why I'm doing this video, because I found myself as I was doing the work to calculate all of the systems I need, the wires I need, and every component of the setup that I need to connect that building to wire it properly up to standards, safety standards. I realized that people bypass these steps, so I wanted to talk about it. So the foundation of the power distribution and transmission into your home is the wires you choose. So now let's talk about the wiring, right, of your home or of your small business in Liberia. So there are two things that can happen here. There are two decisions you have to make. One, you have to make a decision about who to hire to do your work, right? So some of the mistakes that can occur is when a person who is doing the wiring doesn't know how to do the wiring properly. So the way the connection is done, right? There can be a mistake coming from there. And that can lead to fire hazards, fire disasters, right? So that's one thing that can go wrong. The work itself, the quality of the work that is done can be poor. The next thing is the choices of wires that are used in the wiring can be another source of big disasters in homes and business electrification. So if you use the wrong sizes of wires to do the connection, some wires that are not supposed to be running between two different points, and you put the wrong size of wire there, that can cause a fire, and that can cause a lot of damages for you down the line. If possible, it can lead to fatalities in the building. So those are the two things you need to be mindful about. So today we are going to talk about the choices of wire that you use, right? Because the other part is like selecting the right people to make the wiring. That you can find some good like electricians in Liberia, but don't just pick up anyone from anywhere to do your electrification. And that is what most people tend to do. They just look around the community and pick, Sana Ziama from the backyard there and to come and do your connection. Don't choose Sana Ziama from your backyard to come and do connection. Look for a professional person to do your work. So on the wiring part, let's talk about the wiring. First of all, let's discuss wires in general. Now, and the reason why we are talking about wiring, because I talk about how wires, like you choose the wrong wire to run from point A to point B, and that causes fire. The simple one key reason is that you pick a wire that is not supposed to take above 20 amps of current to go through it. You pick a wire, and then that line basically is pulling some 30 amps of current or 25 amps of current, right? That is not sustainable. That can cause fire, and then it can cause damages. So let's first of all step back now and talk about wires in general. What are the types of wire? And I'm going to discuss all the types of wires. I'm going to discuss the main types of wire that are supposed to be used in your home electrification and some of them in your small commercial and industrial building. Those are the ones I'm going to discuss. So the first type of wire we're going to talk about today is called the THHN, which simply means the thermoplastic high heat resistant nylon coating wires, right? THHN, thermoplastic high heat resistant nylon coated. That's what it means. So it means those wires, they have certain type of coatings around them that makes them resistant to high heat situations, right? So the next type of wire, and remember now, so that high heat resistant wire is designed with the nylon coating around it. It's designed to be more flexible because of the nylon coating, but also the wire itself is able to resist some high heat, not extreme heat. So don't take that wire and introduce it in environments where the heat temperatures are extreme, okay? But for the purposes of like your homes and small commercial and industrial buildings, those type of wires are good. So the next type of wire we are going to discuss is the NMB. NMB, or sometimes they are called Romex. But I think Romex is the company that produces these things because Romex is a registered trademark. I need to search that out, deep dive that a little bit. But they are also called Romex wire, but the actual name is NMB. And the NM stands for non-metallic. So they are non-metallic shift cables, right? So that's what the NMB is for. So that means the coating around these wires, they are like made of different materials that are non-metallic coatings. And most of the time, these wires are made of a couple of THHN wires put in this non-metallic coating and wrapped together. So when, for example, you hear people talking about, for example, the wire comes in different sizes, but when you hear people talking about like This wire has 3 wires in it or 4 wires in it, right? So those 3 or 4 wires, they are usually NMB. They're wrapping around those 3 or 4 wire in the cable itself, right? There's a bunch of THHN, right? There are 2 THHN or 3 THHN wires in there, plus a grounding wire. And we'll talk about those in details later on. So those wires, the non-metallic sheathed cables, are designed for homes, for the interior of your homes. Those are the ones you want to use inside your building. Usually the material around the NMB wire is made of PVC. So PVC is very good. It's resistant to like water leaks. It keeps moisture out of the bundles of wire inside that wire tube, and it's applicable to areas where, for example, there's a little bit of moisture and wetness or in the interior of your homes. Those wires are not good to run outside of your building. So again, these are things that you will not hear about, people will not tell you. If you take those wires and run them outside of your building, you are exposing the wire to environmental elements that they are not built to support. In fact, the NMB, the only time you run them to the outside of your building, if the distances are really short, maybe I would say probably not more than 20 feet, right? People have different standards, but I would advise keep it as low as even 5 or 10 feet. That's the maximum. And when you do, for NMB wires, put them in a conduit. So a conduit would be a bigger PVC pipe or some type of pipe that you can use and bury underground. Never expose the NMB to outside elements. Don't put your NMB wires connected outside like that. For example, if you want to run the wire by digging a little trench and lay the wire in there, don't lay the wires bare. And NMB wires are not meant for that in the first place. So keep them inside your house. So the next type of wires is called the MC cables. Or basically what MC stands for is just, you guessed right, metallic or metal clad cables. Those are the MC cables. Now, those ones will be like wires. Again, they are made of several of the THHN wires inside a metal tubing or metal conduit. So it already comes in metal conduit, right? So those ones are used for commercial and industrial interior wiring. Again, those are not meant for outside. And usually that metal clad, so you can think of them as the metal jacket cables, right? Those metal tubings that they come in, those metals are usually made of aluminum, right? So you will find some of these wires and they are really nice. When you use them in the interior of your commercial industrial building, you don't need extra conduits to wrap your wires in. On the contrary, if you use the NMB cables for your residential home wiring, and if it is on the surface of the walls, that's when you put those, you want to put them in a conduit, right? And the conduit sometimes has a lot of advantages. One, it beautifies your wiring, right? Especially if you're wiring it on the surface. And even if you're putting them through the wall, it is better to put those wires through conduit. Remember, we talked about the material that is outside those cables. They are PVC, they are good at certain things, but they're not good at everything. So you want to, for your own safety, I will advise if you put those wires through walls, you put them through the conduits, those pipes that you can pull the wire through when you're installing the wire. So you want to use the NMB for that. And these MC cables, right, the metal clad cables, you want to use them for the interior of commercial industrial building. Why are we having two different types of wire for the interior of buildings that are your residential homes versus your commercial industrial building? The reason is this. As you can already tell, you can get away with using the NM cables for your residential home even if you don't put them in conduit, right? You run them along the walls, right? For Liberia. In the US, for example, people can run those wires in the attics, and sometimes it's advisable again to put them in these conduits, but you can run them bare like that. Now, for the industrial and commercial building, because of the use of heavy equipment and machineries, and sometimes because there are high temperatures and sometimes flames flying depending on what type of work is going on in this commercial and industrial building. For example, it could be like a factory. Because of those harsh environments that is different from the environments in your living home, you want your cables to be wrapped in a metallic conduit. So that is why those cables already come wrapped in a metallic conduit. Besides that, the cables themselves in there, again, they are the THHN cables, right? So they have some protection, but they do not have the metal wrapping already. So you have to bring them in a metal tubes. So that is the reason. In the commercial industrial building, activities that are happening there is different from the activities that is happening in your residential home. Therefore, you want your cables to be much more protected in case there is fire in the building, those cables are already protected in the metal, right? So that is the thing. What other type of wire could we talk about? Oh, here is one. There is one you will see, it's called UBF cables. Now, what that means is that it's underground feed cables. That is the UBF thing, right? Sorry, the UFB. Sorry, it's underground feed cables, right? So there's a UF-B or UFB cables, just like NMB, which is the non-metallic sheath cable. This is the UFB, the underground feed cables. So these underground feed cables, what are they for? They are exactly the piece that we are missing. You may have been asking, but then what type of wire are we going to use for the exterior of our homes? Those are the wires you want to use. So those cables, in fact, they are so good that you don't even need to put them in a conduit when you are burying them underground. So they already come in a material that is protective and protects them from the harsh environments of high temperatures outside, rain, and everything else from the soil can throw at them when they are buried underground. So they can be directly buried like that without conduits. The one thing you want to be careful with, when the wire, before it enters or leaves the building, is exposed to sunlight, right? Before you put it in the ground, that segment of the UFB cable, you want to put that in a piece of conduit. So that is the part you need to always do. Don't leave that exposed to the sun, right? Although it's meant for outside element, but it's advisable, right? In practical use cases, it's advisable you put that in a conduit. The part that goes underground, you do not need to put that in a conduit. And in fact, without putting them in a conduit, you are actually following the best standards already. But if you have extra conduits and you want to be extra protective, you can put them in conduit, but that will just be overdoing it, right? But you can also do that. I myself, I have done it. I'm guilty of doing that. Just because the terrain that I was burying my cable in, I looked at the area, I was like, I'm going to put this in a conduit, all right? And I put that in a PVC pipe. So I said the PVC pipe will be the first layer of defense. And then the wire itself is in a very thick sheath, right? Because it's a UFB cable. But before the elements, deal with this conduit, my wire is in there, it's already protected, it's not even being used. So that means I'm just really like multiplying the number of years of utility of that cable by extra X amount, right? So you can do that as well you want, but you really don't need to. That's the point. So there are other types of wires that we're not talking about, because those ones, like for example, there are those wires that are in like tray cables, right? But we're not talking about those. So these are the ones we're talking about, and these are the ones we are going to focus on. So now the next thing we want to know about wire. So now, when you're choosing wire, first you got to know, is it wire for my interior of the building, or is it wire for the exterior of the building? Is it wire for residential home, or is this wire for commercial industrial building? So for example, for the X-City HQ or the XHQ building, that building is a commercial building, right? Now, but it is a small commercial building. So one could technically, right? This is where you have to be, if you know what you're doing, you can make some trade-offs. Technically, we could go with the NMB cables, which is meant for residential buildings, for the size of that building. It is two-story building. It is not more than two-story buildings, so you could use that for that. The other thing is NMB cables, normally you don't want to do it for very high-rise building, especially for floors that are higher than something like a 4 floors, right? The 4th floor, right? You don't want to use NMB up there too much. That's a different reason. We'll get to that. But let's just focus here now, right? On the choices we can make. So for a building like that, though it's a commercial building, we could judiciously make some money-saving decisions here and say, let's go with NMB. Oh, talking about money saving, let's talk about the cost of these wires. So the UFB cables, the ones for the exterior, and because they are directly buryable, is that a word? Because you can directly bury them underground, they come with that extra protection. They cost a lot more than the NMB cables for your interior. So when you go, you hire an electrician. Sometimes this is what happens in Liberia. Some of these fire hazards are not the doings of just the electrician. It is sometimes the doing of the homeowners. Your electrician advises you sometimes on these are the right wires to buy. And you say, well, this wire is too expensive. Why we can just buy this cheap wire? Because with them at the store, they say, okay, the man wants his job. He doesn't want to lose that contract. He's afraid that if he insists that this is the only wire you should buy for your work, you are going to choose the other contractor who's going to say, well, we can buy a cheaper wire here, so your cost is down. You want to go with the guy who's telling the low cost. So this is in defense of the technocrats, the electricians in Liberia, right? So we always bash them for doing poor quality work, these people, but sometimes it is not their fault. The man is in a tight spot. He wants that contract. He wants to make money, and now he's worried if he gives you the full coat of the wires that you need for your exterior and interior, you're gonna go with the other guy who gives you a lesser coat for lower cost materials. So you have to make these judgments very carefully. Is this man charging you because his labor cost is too high? And sometimes the man is doing good. Actually, I think we are deviating now from the whole topic. But so let me stop here. Let me just summarize this part by saying sometimes the poor decision about wire choices is not the doing of the electrician. It is the homeowners themselves or the project manager. They want to save too much money and they can lead to bad choices. So the UFB cables are much more expensive because again they can resist a lot of conditions outside. The NMB cables are slightly cheaper. Actually, they are significantly cheaper than the UFB cables, to be quite honest. Maybe like 15% cheaper, 20%. So that's a significant amount there if you search for the prices, right? So it's significant price difference there. And then the MC cables for the industrial and commercial buildings, those are even more expensive than the NMB cables, even more expensive than the UFB cables, I think. So this is one area you have to be careful about, right? Making your decision, right? So if there's a commercial building, you're going to spend that money. Let me tell you something. I'm sizing up the wires, calculating how much wire I need for the XHQ building. I'm ashamed to tell you the total cost. Just the wire is coming to. I'm not talking about any other component. I'm saying just the wires that I need to run to do the connections, right? In the building, not even anywhere else, just in the building. It's scary. It's even shameful to tell you because it's a huge amount of money and it hurt my heart. You know what I mean? Like something turning your heart. But again, we have to do the best quality work because if we are preaching people, we are encouraging people to do the right thing in Liberia in our construction, we have to lead by example. But those wires, the price, this thing is painful. It's hot. It's really, really crazy. I don't even want to talk about it. But anyways, so think about these things when you're making the choices of a wiring. Get the right advice. Do not go in trying to squeeze every little dollar penny out of the list or the prices. It's good to find things at a good price, but make sure it is the right quality that you need for the work. Once you establish the qualities of materials you need for the work, now you go on the market, you try to search for where you can get that quality for the lowest price. That is how you do your purchasing. You don't go out in the market and say, I want to buy material at the lowest price without setting your quality bar. First of all, get your line, your bottom line, draw the line in the sand where you cannot go below the quality, and then go look for materials that are at the lowest price for that same quality. That is how you go and buy your materials. That is how I do, at least. So now that we talked about the prices of those wires a little bit, let's talk about the sizes of the wire, because all of these wires we talked about, you can see some wires, the cable is thick, some of them are smaller, and how are wires size, and why does the size of the wire matter? Now, let's talk about this a little bit. So the cables, the sizes of the cables are measured in gauges. So you hear 12 gauge, 10 gauge, 8 gauge, 6 gauge cables or wires, right? That is it tells you the size. The lower that gauge is, the bigger the wire. So it's inverse relationship there. So most of the times, and I'll tell you this now, most of the times, the wires you want to run from your light post, the closest light post to your house, if you are using grid electricity in Liberia, or from your generator house, if the wire comes from the light post, goes into your generator house, and then from your generator house to your building, the wires you want to use there, right, should be, in fact, the smallest wire should be around 8 gauge wire. So it could be higher, like 6 gauge wire, but the smallest you want around there is around 8 gauge wire. So from 6 gauge to 8 gauge, those ones can take from 40 amps of current to around 60 amps of current can pass through those wires, no problem. So they are very thick. They are like, the 8 gauge wire is probably like this thick in diameter, right? And the 6 gauge is probably like big like that, right? So those wires can be really thick, right? Now, those are the wires you are running. Those are the main feeder lines to your building, right? 6 gauge to 8 gauge. 8 gauge is fine, right? For most applications, especially for your homes, 8 gauge is fine. That's what I'm getting, for example, for running the wires, for example, from our solar panels to the inverter box for the XHQ building. And I'm going to get many of those 8 gauge, the solar version of those wires, right? I'm getting it. But the ones that run now from a generator house to the single apartment build room in its apartment side of the XHQ building, again, is the 8 gauge cable that runs underground there, right? So good. We got that clear up. So do not go and buy some 10 gauge wire or 12 gauge wire and run your main feeder power line through that and use that as your main feeder line. That is a terrible choice. You don't want to do that. Now, what type of wire should you use now in the inside of the building? The size of the wire that should be running in the inside of your residential homes. Let me tell you this for free now. If you are in Liberia, your home in Liberia for a residential home, use something like 10 gauge wires. That's my best advice to you. Can you use 12 gauge wire? Yes. But you saw how I said yes on that, right? You can use that, but you are threading towards the risk margin there, right? To be safe, use your 10 gauge wires in there. You want to use your 12 gauge and higher for like small connections inside the house from one thing to something that where you know the electrician here, the guy knows what he's doing, right? You can do that. But to do other main line in your house, I will advise you to use your 10 gauge wire. So those are the things that you need to do. Have you seen, for example, some people who are bad actors or bad customers to the national grid? They are practicing power theft. And because they want to conceal the power theft, they use very thin wires, the smallest wire, I don't know, 16 gauge wire maybe or more. They use those type of wires to get power from the transformer in a community to their building. That is a disaster waiting to happen. Or, for example, the choices that people make, for example, some of these people, it's not because they don't have money to buy the wire, and that's a sad thing. Sometimes it's because they do not know. And the people who are doing the job may not be the best people to do the job because they themselves perhaps do not know the best practices in what wires to select. That's one. The other side is the one where I said, sometimes these technicians, they know the best practices and they will tell the client will say, I want to save money. So the client goes and buys some very cheap and poor wires. And the client wants to get money from that job. So he goes ahead and do the job. He make do with what he has. It is time for people to start to make better decisions. Stop making do with what you have. Like, it's time to make the best decision from the beginning. Think about it. Instead of buying 10 gauge wire, you go and buy 14 gauge wire and wire your home, or 16 gauge wire because it's cheaper. You wire your home. You save money today. You save a couple of thousands of dollars sometimes, right? Or sometimes it's saving like maybe a few $100s, right? Today. But tomorrow that can lead to a loss of what? Your entire home. Maybe that's a $75,000 or $50,000 home or $30,000 home because you wanted to save $2,000 on your electric wire choice. And sometimes the homes that are catching fire are expensive, super expensive. We're talking about 250K to 300 or 400K homes that get burned down simply because somebody, whether knowingly or unknowingly, make a decision to buy a wire that costs maybe, say, $100 for a 100-foot wire instead of spending $200 for a 100-foot wire, right? Because those two wires, although they are the same length, but they are different gauges, the guy go and buy the cheaper one and say, it should be fine. Yeah, it's fine. It's good. And you go ahead and do your wiring. So Liberians, we need to make better choices, especially when it comes to electrifying your home. If you make the poor choices, you are going to regret, it's painful. You're going to make some choices that feels good today, but it's going to end up to be a very costly choice. These fires lead to the loss of properties and sometimes lives. So let's not take this as something we should always try to economize on. Let's be mindful about the choices of wires we make. Piece of thing that we didn't touch on is those cables, right? I talked about them having two wires inside with one ground cable. Usually the grounding wire is usually exposed pure copper, or sometimes there are 3 wires in there and that copper cable, which is the grounding cable. The ones that so when you hear, for example, if you are buying 10 gauge wire, you have to decide whether it's 10 by 3 or 10 by 2. 10 by 2 wires are the wires that have 2 conducting cables, the ones that carry electricity, and 1 grounding cable, right? The pure copper cable that ground your entire system. That is your 10 by 2 cables. The 10 by 3 cables will be the 10 gauge wires that carries three conducting wires, sorry, and one grounding wire. Usually that copper wire is sometimes exposed copper wire because it's grounding cable. So it carries 4 wires in them, but it's called 10 by 3. So those wires, for example, the one with the two conducting cables and the one ground cable, those two cables are called sometimes the two hot legs, right? Or the two loads, right? L1 or L2, or the two hot legs. That means those are the ones that are carrying your power, the two power lines, and then the grounding cable. And then the wires that carry the three conductors and the one grounding cable are the ones that carry, like, the three legs are, the first leg carries a hot line. It's carrying maybe a 110 volt. The other one also carries a 110 volt. And then the third one is a neutral line. And then the fourth one is that grounding cable, right? So the two 110 cable, when you combine them, they give you 240, right? But then you combine that any one of those hot legs with the neutral cable, you get 110. So those are the wiring where you get a system in which you wire the house. You get both 110 and you get 220 outlet. For example, in XHQ, we have both 110 and 220 outlets in the apartment side. We haven't wired the entire building to the other side. And again, I'm sizing up that system, designing everything that we need to use to wire that. But I can tell you, that thing is painful. I shouldn't lie to you. Like, the cost of the wires alone that I'm getting in that building, it's crazy. I'll let you know at some point, once we get out of the wires, where I land in terms of my decision between buying the MC cable for the interior of the XHQ versus buying the NMB cable for the interior of the XHQ. Remember what I said about NMB? They are good for the interior of residential buildings. MC cables good for the interior of commercial and industrial buildings. Now, is the XHQ going to have that industrial and commercial activities that requires that type of extreme protection for the wire, like being in a metal tubing? So again, I have to make an economic decision there. But again, we are preaching highest quality. So I'm basically exposing myself here, right? I'm telling you, like, if I come tomorrow and tell you I chose the NMB cable, you have right to say, why did you? Of course, I'll have technical reasons to tell you why I made that choice. But again, if I come back and say I finally picked the MC cable, then I'll be deserving applause, because that would be a small burden on my purse. Even the NMB cable, the burden of the NMB cable on my purse is super, super huge. I shouldn't lie to you. It's massive. It's like, it makes me, seriously, it makes me want to cry. And we are not talking about the system I'm buying. I'm not even talking about the generation. The generation for that building, I need to buy the inverters, the battery banks, the cables that run from the solar panels up the building that will come down to the inverters, right? So those are all 8 gauge cables, right? And I need about 10 of those 100-foot 8 gauge cables. Go and check them out. The solar cables 8 gauge. Just look at the price. Go check for the price, and then you will come back and feel sorry for me and moon along with me, right? And then we're talking about the solar panels for that system size that we're trying to build, right? So yeah, I think the price is getting me choked. So I'm not even talking about the price of that part, right? From that inverter box, the battery banks that I need, the size of the battery and the cost of that battery, that thing is a killer too, right? And then the wires that I need to run from the solar panels down, and then the solar panels, that is not even part of this cost that I'm concerned about. Because, I mean, I'm not saying it's small. That stuff is crazy, super astronomically high. But we are talking about wire sale because that is what concerns everybody on this channel. And I'm just telling you that I share your pain. But we all have to make the sacrifices to buy the best quality materials for us not to suffer a disaster that is much, much more costly than what we will save today. The other thing about designing your solar system, let me talk about this a little bit before I go. So as I'm designing the solar generation, the solar power generation system, I want to design something so good that that XHQ building will not have any need for grid electricity. If grid electricity comes, fine. If it doesn't come, nobody cares. That's how I want to design it. So it's going to be costly. And then to minimize my cost, I have to make some decisions. I have to be able to technically connect different component parts and put them together and make them work, because some components, they are the same quality in different marketplaces where I could potentially buy them, right? They are the same quality in practice but different prices. So for those cases, I want to buy the one that costs the least amount, because in practice, they have the same quality and the same build structures, and they fulfill the needs I have. So I have to make some of those choices. There are some cases for this solar system that I'm designing. Let me just give you a typical hypothetical example. I will see a component in one market, it costs $10. That same component on paper, the performance is the same with this other same component in another market, it costs $100, right? But I am going to make the choice to buy the $100 component over the $10 component because although on paper they both fulfill my needs and the qualities are the same on paper, but in reality, in practice, they are not the same. They don't have the same durability, and the maintenance and the operation headache of the $10 thing is way, way too much, right? So those are the kind of choices that I am making now and I've been making and I'm sharing with you so that when you're making your choice, think about these things. Electrical components, and especially things that supply power to your building, you want to get the best quality, the most reliable ones, the one that will lead to the least downtime, right? The time during which you're not able to operate because something broke down. You don't want those. You want to eliminate downtime or drive it towards zero as close as possible, right? So those are the kind of choices I'm making. So that system is giving me a headache. I'm sourcing things from everywhere in the world. Nowhere is out of scope. But at the same time, I need to make sure that I'm getting the best quality. And some of the most critical systems, I'm buying in directly from in the US, things that are made in the US or at least designed and quality checked in the US, even if they are manufactured elsewhere. But I'm going to pay that huge amount of money, sacrifice, bite the bullet, buy those components because it is the best thing for the long term for XHQ. So I see the price differences. It's crazy. It's tempting, really tempting, but I won't make those choices. And I want to share those with you so that you know when you're building your homes in Liberia, you want to go and have like the best of time in Liberia and sit without any problem. Do not make too much of shortcut decisions here. Don't make poor choices. Or else, when you retire, for example, and you're not making that much money, and you go, but then every minute you have to change this on your house or change that. Like, where is that money going to come from? I have an example of one ex-citizen who basically has been building a home for himself, but the quality of that home that person is building, I went there and I was impressed because the reason he told me when I retire and come back, I don't want to pay a cent on repair work, and that made a whole lot of sense. So I'm advising you when you retire and go back to your home in Exeter or elsewhere in Liberia, make sure that home is built to last. Thank you and have a wonderful day. Bye bye.